Hi guys, welcome back to the channel. Today we're going to write a crypto price tracker, which is going to scrape the prices of a bunch of cryptocurrencies and then put the data in a time series database called QuestDB to analyze the data later on. QuestDB also gives you some built-in graphs where you can see how your cryptocurrency's price is trending over time. So you can also use that to get a quick idea, but ideally you want to use that data to back an API, which is going to be called by your front-end service. Here I have a small architecture diagram to show you how it's going to work. At the center of it is going to be the Python program, which is going to call the API, get the data, and then write it to the database. So this is going to be your main logic over here. We're going to make this program run every minute by writing a shell script, which is going to go to the directory and just run the Python program. And then we're going to schedule the shell script to run on cron every minute. I'm going to go over both the shell script and the cron job to show you how to schedule it to run every minute. The program is going to call an API called CoinGecko. It's a pretty simple and free API you can use to get price details about any coins. Once it gets the data and then formats it correctly, we're going to put the data in a QuestDB database. QuestDB is a time series database. It gives you a lot of easy ways to query your data in a time-oriented way. So let's say if you want to find like average over the last 5 hours or any kind of query that is something to do with time, QuestDB is very, very performant as opposed to a basic MySQL DB. Because QuestDB was designed from the ground up with time series data in mind. So they did a lot of optimization that you don't get out of the box from a MySQL or Postgres. So we're going to put the data in the QuestDB database. QuestDB also gives you a kind of a UI you can use to see how your data is evolving over time. It's pretty basic in nature, so you don't want to use it for any advanced analytics. But just for a quick look, we're also going to look at the graph that QuestDB gives us. And here as a user, you can just look at those graphs and charts to see how your data is evolving over time. When it comes to running the QuestDB database itself, we are just going to run it locally using a Docker image just from the Docker registry. The Docker image that you get if you spin it up, you're going to pretty much get both the database locally and also the UI where you can see your data or run queries. We're going to look at both too. So before any longer, let us get started with the code then. Alright, so over here I have a pretty rough number of steps to kind of guide you through how we're going to do it. The first thing we're going to do is create the table, and then we're going to make the API call to CoinGecko. Once we make the API call and get the data, we're going to parse the response to get the prices. After getting the prices, we're going to insert them into the QuestDB. It should be a pretty simple insert statement. We're going to see the new data in the table and kind of play around with it to see how it works. At that point, the program should be done, and all we will have left is to do the shell script and the scheduling. So the next step naturally is going to be to write the shell file. So I already have it over here. You see a cron script. I'm going to show you how to write that file and explain all the logic in there. Once we have the shell file running, we're going to schedule the cron job to run the shell file every minute, which is going to trigger our Python script every minute. We're also going to see how to schedule a cron job very easily. And lastly, I'm going to go over a few queries we can use in QuestDB that we would not have gotten with MySQL or Postgres. So yeah, with that being said, let's start the coding then. So the first thing we're going to do is import the packages that we need. So the two packages we're going to be needing is the datetime, which is going to give us the current date, and then typically the requests package, which is going to let us make the API calls. And I already have all the packages installed in my environment, so I'm just going to make sure it can still find it. So we're just going to do Python. Let me just see what's the name of the file. Let's just go script.py. So we're going to just run it. and it runs without an issue. That means the packages are installed correctly. If you're doing it from scratch, just install the package using pip install. That should do it. We'll take a pause here just so that I can show you quickly what the Quest UI looks like. So over here, if we go to so the first thing is our Docker image, which you can see over here. We have QuestDB Docker image running, and it's been running for the past 2 months. So we've been scraping data on and off for the past 2 months. So to give you an idea of how the data looks like, we could just go to there you go. So this is what you get from the Docker image by default. So you have a cool UI way to look at things. So if we do a quick run of, we'll just look at the, currently the data is in a table called crypto prices. So if we just run it, you can see we have like all the coins, prices, and time over here. So to give you an idea, there's the coin, and then you have the price, and then you have the time. And we have a total of 25,000 rows. And if I run the command again, you see it took us only 6 milliseconds to get all the data, which is very, very performant. So now going back to the code. Let's see, there you go. So we imported the packages. The next step is to actually make the API call, right? So this is going to be our price URL. This is pretty much the base URL of the CoinGecko endpoint that we're going to call. So we can call the endpoint with a bunch of coin IDs to get the prices for all of the IDs. That brings us to the next thing, which is the coin IDs. So we're going to use a few. We're going to use Ethereum. We're going to have Bitcoin. We're going to have Cardano. We're going to have Solana, Chainlink, Graph, Audius, LivePeer, and then Rally 2. So these are going to be all the coins we're going to actually scrape. The next step is to, now that you can see all of them are in a list, so we want to actually make them into a comma separated string. So we're just going to join all the coin IDs using a comma. And at this point, let's just print it out to see what we're getting. There you go. We're getting all of them in a string separated by comma. That's exactly what we want. So before making the API call, what we're going to do is go ahead and create the table in the first place. So creating a table is very, very simple. So we're just going to run the command over here, which is a generic create table command from MySQL. So we're just doing a create table, the name of the table. In our case, we're going to do, let's just do demo. So it's going to be called crypto prices demo. And then we're going to have 3 columns. One is the ID. And then we have the coin, we have the price, and we have the timestamp. So by default, ID is just going to be incrementing automatically. We have the coin, which is the name of the coin. We have the price, which is a double, because the cryptocurrency's prices can be very, very small, so you don't want it to be an integer. And then the timestamp is, TS is going to be timestamp, which is just when the data was collected. One small thing that you have to do in a QuestDB create query is explicitly mention which of your column is the timestamp column. So we're just using the timestamp function and specifying that TS is the column which is going to have the time data. So with that, we're going to run it. And we're going to refresh. And there you go. We have the crypto prices demo table over there. If I do a quick select query, crypto prices demo. If we just do a quick select query, you can see we got 0 rows in 1 millisecond because the table is empty right now. All right, so going back to the code. So now that we have all of the IDs joined by a comma, we're going to actually format our full URL. So what we're going to do is pretty much do, just go level up. We're going to do full URL is the formatted string. The first thing is going to be the price URL, which is the base string. And then to that, what you want to do is just add the query parameter, which is going to be IDs. This is a comma separated list of all your IDs. In our case, that's called coin IDs query. And we need to give it the currency that we want. So we want it in US dollar. So we can do USD. We're just going to print the full URL so that you can take a look at how it looks. There you go. So we have api.coingecko.com, API v3, simple price, and then IDs is the comma separated, all the coin IDs, and then we have the currency set to USD. That's the URL. Now let's just make the call. So we can just do response equals requests.get, and then the URL. So it's just gonna make the API call. And then let's just print out the response, which is gonna be .json. There you go. So if you look at the prices in JSON for Ethereum, we're getting 3,392, Cardano 234, Solana is 143, Audius is 271, Chainlink is 2776. So you have all the prices in a very, very clean way. So now let us go through each of the coin over here and then insert them into the database, right? So we're gonna, let's just keep the response. Then this is a dictionary we're getting, so we can just do for key value in response.json and then .items, which is gonna give us both the key and the value. And then we have the coin ID, which is the key, and then the coin value in USD, which is gonna be the value and then USD. That's because if you look at the value for every key, so for Ethereum, the value is a dictionary, and within the dictionary, we have to go get the USD value. So at this point, we have the ID and the price. We need the current date time because in a time series database you always want to insert date object because that's how you keep track of time. So we're just gonna do datetime.now and we're gonna convert it to a string because when inserting into the table we need it in a string format. Alright, so let's actually go ahead and print it now. So we're gonna do coin ID, comma, coin value in USD, and then the current date time. Let's run it. So we get Ethereum, the price, and then the whole date. And for similarly, we get it for all the coins. So perfect, that's exactly what we want. The next thing is to insert query itself. So it's going to be a very simple SQL query. So we're going to have a formatted string. We're going to do insert into the table. Our table was called crypto prices demo. And then we're going to write the keys that we're going to insert. So that's going to be coin, price, and the time. And then the values, each of them is going to be a string. So we want to just close it over here. And then we can just do 2 commas, and then we can do key. That is, we're just using the formatted string format. We're gonna do coin value in USD because this is not gonna be a string, this is gonna be a number. And then the time is gonna be a string. So once again, we're gonna put it over there and then just do current date time. There you go. So it's pretty simple. We're doing an insert query, giving it the keys that we're inserting, and then the values over here. That should do it. And then when it comes to, actually, let's just print the query so that you can take a look how it looks like. There you go. So we're gonna make these insert calls. We could also make like a bulk call, but I think for simplicity, we're gonna keep it like this. So we're just doing an insert into the table, the three columns, and then in values, we have the tree value. So pretty straightforward. We have our QuestDB server running locally. So let's just make that request. This is going to be also very simple. We're going to use requests again. Do a .get. Then we're going to use a formatted string where we use our local host. By default, QuestDB runs on 9000. We're going to use the execute endpoint, and then we just give it the query, which is going to be our insert query. That's how you pretty much go. I think we're missing something. We're missing another parenthesis over here. Nope. And close this one. Oh, there you go. That should do it. That did not do it. So let's see. We have the formatted string, and then we have the whole thing, and then we have this should be here. There you go. That should do it. So we have the insert request, and we're just going to print the response we're getting. And also, let's print the query. There you go. Perfect. If we run it, there you go. So you can see we're making a query, and then we're getting an OK response back from the database. So we should be good. Now let's go to the table and see if the data is actually there or not. So we're going to run the select command again. Last time it returned to a 0 rows. And there you go. So we're getting coin, price, and time. So for ID, I think we should have been auto incrementing it because right now it's just doing a null, but we don't really need the column, so we should be good. So if we just don't look at it because we don't need it, we can do coin, price, and TS. And running it gives us the coin, the price, and the timestamp. So that's exactly what we want, right? So with that being said, let's see what's the next thing we want to take a look at. So now we have a working version of the full program that we wanted to write. And so we did step 4, we did step 5. Step 6 is to write the shell file. So I already wrote it for you over here. So what it's doing is it's doing a echo hello world just to show me that the file is working. It's going to the directory relative to the home directory to where the script lives. It's sourcing the Python environment so that we get all the packages that we need. And it's just running the Python 3 script.py command. So this should just directly run you the script. So I think I can just show it to you over here if we do a cron script. Yeah. So you see a hello world, and then we get all the print statements that are coming from the program. So that's how you pretty much write a very simple shell script to execute your Python file. Now the next step is to actually make cron run the shell script. It's very, very simple to do that. You can just go to, I can just show it to you from here. We can just do a cron tab. All. So here's the cron file, and it has pretty much this tells you, this is the cron syntax, just tells you to run it every minute. And what to run every minute, you have to supply it with a shell script, which is going to be the shell script we just wrote. And this should just run it every single minute. So I think you can do something like, yeah. So if you do -e, you can actually go ahead and edit the file, right? Let's see. So not very familiar with Vim. I think we can just do Control X. Oops. Nope. Insert. Okay. So yeah, if we do I, you're in insert mode. We're gonna get out of insert mode. We're gonna do column Q. So we're gonna do column WQ. There you go. So now if we look at our cron tab, there you go, we have the script running. So this is how you can write any shell script and then just schedule it in cron so that your computer, even when it's on sleep, it can just run the command. So now we're done with step 7. So we have let's just go back to the architecture diagram. So we have the full thing running properly. The table is populated. We have our program running. We wrote the shell script and the cron job. So now everything should be working as expected. So let's look at the last part, which is the UI part. For the UI part, we're going to be using the other table, which is populated, because for this table we just have 63 rows, so you won't really get a good idea of how it works. So we're just gonna do same thing, but we're gonna get it from crypto prices too. So this table has 25,000 rows, so we can get a clear picture of it. So a very cool thing you can do with QuestDB is you can go to chart and you see the 3 fields, chart type, labels, and series. So what you can do is we can do a line chart, and then labels is going to be your y-axis, which we want it to be the price. And labels is going to be your x-axis, so that's going to be your time. And series is going to be the y-axis, which is going to be your price. So this is how it looks like. We have line, time, and then price. If we draw it, let's just do it for one of the coin. So we can do where coin equals Bitcoin. Let's see what's happening here. So we have coin. Right, so it should be the other way around, right? So the label should be the time, and the series should be the price. There you go, perfect. So we have it as a line chart, label is the time, and series is the price. So you can see how the price is changing over time, which is pretty cool that you can do that. We can do the same thing for other coins. What is the key for? Oh, yes. Let's just do it for the other one, which is gonna be Ethereum. Oh, okay. So this keeps on resetting. So we just have to do this. And then we just have to do this. We should be good. There you go. So we get all the prices over here. So it's a pretty easy way to just visualize it, but it's nothing fancy. For that, you have to actually write a front end to do that. Alright, so we're done with that. And the last thing I want to show you is a few sample queries that you can run with this database. So you could do something like this, which is not possible to do in MySQL easily. So you could literally do something like give me the average price of Cardano every 5 hours. Sample by 5 hours is doing that. If we do that, if we go to grid, now you see the prices of Ethereum every 5 hours. Right, so if we go all the way down, that's a lot of rows. So instead of 5 hours, let's do something simple like 2 day. Alright, so this gives you the price every 2 days. We're starting with 9.8, 9.10, 9.12, 9.16. So every other day what the average is like. We could do every 1 day. There you go. We could do every 1 day, which is also very, very useful. And instead of average, we could do the max by every day. So you can see we get the max of Cardano price every day. So these are pretty, and one thing to point out, look how quickly this runs. In 2 milliseconds, we're getting the result. And I know 25,000 is not a lot of rows, but QuestDB scales very, very well. So yeah, I think that is pretty much all I had to show in the video. Hopefully y'all learned something new from this one. If you have any questions or concerns, just leave it in the comments below and I'll take a look. And with that being said, thanks for sticking to the end and watching the full video. I will talk to you all later. Bye-bye.